Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the Hess law and Kirchhoff's law. Let's talk about the Hess law first. Hess law of constant heat summation states that regardless of the multiple stages or steps of a reaction, the total enthalpy change for the reaction is the sum of all changes. This law is a manifestation that enthalpy is a state function. His law is named after Germany Henry Hess, a Swiss-born Russian chemist and doctor. Based on his law, it's possible to break a chemical reaction into multiple steps and use the standard enthalpies of formation to find the overall energy of a chemical reaction. Standard enthalpy tables are compiled from empirical data. Using these tables, it's possible to calculate whether or not a more complex reaction is thermodynamically favorable or not. For example, for the three reactions, we have relation for the three reaction heats. Can you find the relation of the three reaction heats? Now, let's talk about the Kirchhoff's law. Kirchhoff's law describes the enthalpy of a reaction's variation with temperature changes. In general, enthalpy of any substance increases with temperature, which means both the products and the reactants' enthalpies increases. The overall enthalpy of the reaction will change if the increase in the enthalpy of products and reactants is different. Kirchhoff's law is named after Gustav Robert Kirchhoff, a German physicist. If the actual chemical reaction is not conducted at the reference temperature, instead of at any temperature T, the constant pressure thermal effect Qt is, as shown in the figure. The constant pressure thermal effect can be expressed as, which is the sum of standard heat output and the difference of sensible enthalpies for products and reactants. For ideal gases, we have. Now, for reactions between the two temperatures, the thermal effect difference is, if the two temperatures are quite close, we have Kirchhoff's law. Kirchhoff's law relates the heat of reaction with the total heat capacities before and after the reaction. Consider the process in which the reactants at state A and temperature T1 are converted into products at state B at temperature T2. Assume that all operations are carried out at constant pressure. The conversion may be carried out in two ways, but according to Hess' law, the total heat change must be the same in both cases. The first way is the reactants at state A and temperature T1 are heated to a temperature T2. The heat absorbed is. The reaction is now allowed to take place at this temperature, and the heat change for the process is. The total heat effect for the process by the first way is. The second way is the reactants in state A and temperature T1 are considered two products at state B at the same temperature. The reaction heat is. The temperature and the products is then raised from T1 to T2, and the heat absorbed is. Then, the total heat effect for the process by the second way is. From the Hess's law, we have this relation. With very small temperature differences, we then have. This is, again, the Kirchhoff's law. Okay, that's all for this task. Thank you very much, and see you next time.